Welcome to GitHub. This is a repository where people can upload any code that they want and share with the world. In this tutorial, I'm going to show you how to access notes from GitHub and then use pandas when working with large data sets. So the first and easiest way to get code from GitHub is simply to download the zip file. Go to this green button and click Download Zip. You will be able to download a folder with the name of the repository and master at the end. You can now unzip it and you'll see here a PDF that'll help you get started. Specifically, I want to draw your attention with how you can download a repository in the quote-unquote proper way. If you go download git bash, you will be able to clone a repository. Essentially, this is a way to keep track of an online repository when changes are being made. So if new sections are uploaded or changed in the future, then you don't need to download the whole zip folder again. You can simply use git reset hard to reset the repository to the original state, and then git pull to access the new notes. Okay, now we can open Anaconda. While that's happening, just going to delete this one. Paste all of this here. Okay, and launch Jupyter. Now, if you go to Unit 1, you'll see that it is a Jupyter notebook consisting of both markdown cells, like this, you can play them, and coding cells. You can go through all of these unit notes in your own time. I just want to draw your attention to the help section. If you need extra background on Python, you can come over here. There's a lot of extra information that you can use. And I also want to draw your attention to slicing. Now I'll get to that in just a bit, but essentially it's a way to index a part of an array from a certain section to a certain other section. So for example, if you have the string hello, consists of 5 letters, which would be 4 up to 4 indices, but if you wanted to slice, let's say just the middle of the word, you would go from 1 to 4 to have that L part. Okay. Now you can go through the other notes in your own time, but I want to draw your attention to pandas for a moment. Essentially, pandas is a Python library that helps you to deal with large data sets, and the name itself is derived from panel data. Okay, so you'll see in this notebook we have NumPy, Matplotlib, and then pandas as PD. I imported Matplotlib inline here so that the figures don't take up too much space. These first few notes help to explain series, how to index them, and how multiple series can come together to form a data frame. Again, this is very useful background information when you start using pandas for work. Now, I want to get to these examples down here. So you'll notice that with this Python tutorial, there is a folder called assets, and underneath it, it contains XRD data, a folder with 2 Excel spreadsheets, and this other one here, experimental data. Right. So what you can do with pandas essentially is import that Excel spreadsheet as a data frame, and then you can access specific columns and plot them. This example over here is that of 2 XRD plots for amorphous Zane samples, and I'm going to show you how to recreate that today. So let's say we want to draw 2 XRD plots on our own. We're going to go to, let's say over here, and I'm going to create a new Python 3 notebook. I'm going to call it, let's say, XRD plots. Right. So to work with these plots, it's always a good idea to import the big 3 libraries. Okay, so this will enable us to work with numerical data, to plot data, and to access panel data. And because I just want to keep the plots tiny and out of the way, there we go. Okay, so the first thing we'll want to do is access our data. Now, you'll see that my notebook is over here and the plots are over here. It's 2 Excel spreadsheets that simply have data in them, wavelength and intensity. So if we want to access them, either we can copy them to be here with our notebook, or we can tell Python to go look down a specific file path. Okay, so that's what we're going to do now. To do this, we're going to use the read Excel function. And if you can't remember a function's name, you can always press tab and suggestions will pop up. Now, the name of these files need to be specified. So I'm going to go down here and find the path. Remember, we need to swap these to forward slashes, and then finally give the names of the Excel sheets. So in the first case, take this dot Excel SX. See if that works. Bob's your uncle. There you go. Now, when you import a large data set, it will show the first 30 and the last 30 data points, as well as how many rows and columns there are. Because this data set doesn't have a header, I'm going to add in this option, header equals none. Right? And it'll supply a 0 and a 1. Now, if you don't know how I got this, always go read the help. So for any function, if you type a question mark after it, you'll be able to see all of the different options that you have. And you'll see here, if header is specified here, If a list of integers is passed, those row positions will be combined into a multi-index. Use none if there is no header. There you can see everything you can do, and you can even specify a specific sheet name in the Excel document if you want to work with it. Okay, now because we are going to be working with this data a lot, I'm going to give it a name, df for data frame. That shouldn't change anything. And then I want to give these headers names. So that should be df columns, if I'm not mistaken. Okay, obviously remember that each of these are their own strings. And you have the two names over there. But because we want to access these two columns separately, we'll want to give them different names. So I'm going to use WL for wavelength, and I'm going to assign that to data frame wavelength. And so if I type WL, there I get the information contained therein. I'm going to use IT for intensity. Right. So let's see what this data looks like. I'm going to plot wavelength on the x-axis, intensity on the y-axis. You can find the symbols on Google if you want. And for now, just intensity, which does not have a unit. Okay, so there is our XRD spectrum, but as you can see, it's very noisy. So we'll want to smooth that out. Okay, so to do that, we can use a specific attribute of a data frame, which is called the rolling attribute. And this will take our data frame and group it into a specific window, after which we can smooth it. So to illustrate that, I'm going to type rolling and press tab to finish that up. And you'll see that when you use this attribute, if you specify a certain window, it's going to group all of the data points in specific groups, for lack of a better word. So I'm just going to specify 10 for a start. And then I want to take the mean of each of those 10 values and use it to replace the one in the center. So once you do this, you're going to lose the first 10 values in your data. So to illustrate that, let's call this smooth. And let's plot it. So you'll see that there is some difference, but not a lot. Maybe if we increase the window to something like 200. Now that's much better. Our data is smoother, but because of the window replacing the data at the end of each group, our graph has shifted to the right. Now we can fix this by going back to the help and seeing what options they have. So if we go look at the help again, They give an example here at the bottom of a data frame containing 0, 1, 2, nan, and 4. And once you have applied the function, the average of 0 and 1, no, of nothing and 0 is not a number, nan. Thereafter, between 0 and 1, it's 0.5. Then between 1 and 2, it's 1.5. 2 and not a number is not a number. And 4 and nothing is also not a number. So, that's an explanation of how this works. But if we want to center it, we'll have to use this command. So by default, center is set as false, and now we can set it as true. So now those nan values are distributed at the front and at the back of the data frame. And the graph has moved back to the center. If you want to see just the first bit of a data frame, by the way, you can use head. You can even specify how many values you want to see. So this shows that the first 10 values are not a number because of this rolling average that we are calculating. If you want to see all of the values, or where the values start without these nans, you can use drop na and then look at the head. So the first values from 0 to 99 are not numbers, and then from 100 we have our first real numerical values. Okay, to illustrate this further, just quickly going to change this to an interactive notebook. Might have to restart and run all. Okay, we can use this button to zoom in on a graph, and you'll see here these first few values don't have an orange line. They are averaged and then that value is calculated and placed over here. Okay, now because this blue is very dark, we may want to make it a bit lighter and apply a legend. So we can say I want to label this as the raw data for sample A, and I want to make it slightly transparent, so I'm going to specify an alpha of 0.3. This one I'm going to label smooth. Okay, now we can add in the legend and ensure that its location is supplied as the best. Okay, very good so far. Let's add in the second spreadsheet. To do this, we're going to do the same thing that we did over here, except now we're going to call this 1b. And I'm going to call this data frame 2, df2, 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 wavelength 2, intensity 2. Right. Also going to apply the smoothing function, and then we'll want to plot it. IT smooth number 2, and it's gonna be raw B. So let's see how that works out. Can we see df2? Yes. Smooth 2, let's plot it. Okay, obviously just ensure that your IT2 is set here as well. Then when you run the plot, again you will see that these two figures are very difficult to compare. And this is because the relative intensity for both of these two are very different. So to help compare them, we're going to normalize the data by dividing by that very first smoothed value so that they can show up in proportion to one another. So to get that first value that we should use, let's see here, my smooth, what that looks like again. So there's a lot of nands. If we drop them, see the first value is there, 100. And I want this value to use, 4327. So let's say I want head of the data set, only number 1. Okay, so now we've got a value, but this value is still in a data frame. This value is index 100. So you can think of this as a column with many rows, and the only row that has something in it is row number 100, which is this one, and the other rows are empty. So we want to change this into a single value. For this we can use float to transform it into a float with decimal places, or int to transform it into an integer. There we go. So I'm going to call this factor, with which we can divide, and then factor 2 for smooth 2. Okay, and now what we want to do is divide our intensity and our smooth data by these factors. There we go. This is a much better comparison, and we can see where the peaks have stayed the same and where changes have occurred. But now this isn't just intensity, it's normalized intensity. And we can now scale the figure and save it. So plotlib line, go back here. Okay, if we want to change the figure size, you will want to save it first in the right aspect ratio. Alrighty, so let's say our aspect ratio for the figure is 4/5. If we want a full size figure, let's say you're making a document and you want the figure large and in the center of the page, we're going to, let's say, specify a value of 5 times aspect ratio. But if you want to have two small figures next to each other in a report, then you can save them as half size. Let's use 3 times 3 times the aspect ratio. Okay, so now add in here full size. Oh, of course, you first need to specify the name. It's a keyword argument. There we go. And if you want to save it, you can call it, let's say, XRD graphs, and now you can specify PDF, SVG, PNG, JPEG, whatever you need or require. I'm going to choose SVG for now. And remember to place savefig before show, otherwise you'll just get a blank graph. Go down to documents, you'll see your beautiful figure. And the great part about saving as an SVG, when you zoom in, you don't lose any quality.